Hello. This lesson continues with our discussion on Euclidean geometry. Now, we had started discussing Euclidean geometry in one or two videos before. And this section that we are looking at is the section of polygons. We already seen one section of polygon in one previous video. We are still going to continue with polygons today. And in very specific term, a polygon is a plane which is closed or a closed shape consisting of three or more lines, okay? So you would think of a plane which is a closed shape and it's consisting of at least two or three lines, very much like saying each time you connect three lines, you form a shape which is a closed shape most of the time. And this closed shape is what we call a polygon. So you could draw three lines, you form a triangle, and a triangle is a polygon with three sides. You could draw three lines or four lines, and you form another shape. This time, possibly a rectangle or some other shape, a polygon with four sides. So in a very specific term, a polygon is a plane, normally a closed shape consisting of three or more line segments. Now, the polygons we are going to be looking at will be very specific polygons of very regular shapes. So here are a few examples that you can see. This is a polygon. It has got how many sides? Four sides. This being the first, the second here, the third, and the fourth. This is another polygon with four sides. This is another polygon with 1, 2, 3, 4, 5, 6 sides. And this is another polygon with what? 3 sides. The polygons we are going to be looking at will be having very specific names and very specific properties. We will be discussing those properties and we'll be using those properties to help us generate or find some unknown quantities required inside the what? Inside the polygon. For example, the first polygon being this other one with 3 sides. Side AB, this side AC, and this side BC here. Well, in some of the previous lessons, we had already seen that a polygon known as a triangle has got several other properties. We discussed a few properties. Today, we will look at, a few other properties possibly before we conclude. Now, the next polygon, apart from triangle, is this other one called what? Called parallelogram. Now, this type of polygon, which we will be discussing immediately when we are done with what? When we are done with this type of polygon called triangle, this polygon also has got a lot of properties. One of them being the area, which can be calculated when we know the base B and the height H, indicated here as B and here as H. For the height. Then the next polygon is called a rectangle. A rectangle is a fairly common, common kind of polygon. It's a common shape. We basically meet it every day of our life. We will also discuss it, a number of properties. One of them being the area, which can be calculated when we know the base and also the height H. The other polygon we are going to be looking at is called a rhombus. Rhombus is this type of polygon here. We will be investigating all the different properties of this type of polygon called rhombus. We will also include in our discussion the area of a rhombus, which can be calculated when we know the side AC or the length AC and the length BD, which we multiply then later divide by 2. Then the other polygon is going to be a square. It's one of the polygons we are going to be investigating. We will be discussing also this type of polygon. Now, this type of polygon is a very interesting one, as we will see in its property, which will be discussed shortly. Then also we have what? We have this other polygon, which is called a trapezium. Now, a trapezium is this type of polygon, well, which very much looks like the top of a roof, okay? Yeah, so you see here, this side, this, and this other one. Basically, there are also 4 sides, very much like this one up, but the difference is that they have very specific properties, which are very different from these other ones here. One of them being the what? The area. You see, the area of a trapezium can be calculated in a much different way from the area of a square. Then the other property, which we'll also be looking at, is called a kite. Rather, the other polygon is called a kite. So a kite is, a polygon of this shape with what? 4 sides. This is one way of calculating the area. Well, this polygon called a kite is a polygon which we will also be looking at into detail. So in total, we will be looking at a kite, we'll be looking at trapezium, we'll be looking at a square, we will be discussing a rhombus, we will later discuss a rectangle, then a parallelogram. But we would like to continue with our discussion first with triangle. We had already seen a triangle. That is, we had discussed a triangle, the different properties of a triangle, how it behaves, how it can be described, stuff like that, the names, the other properties. The other property we had not discussed was what? The area of a triangle. But before we look at the area of a triangle, we would like to look at, this general property that we looked at previously. So I will be sharing right away this screen where we are going to be having, yes. So there we go. Now, right here on the screen, we have, as a quick reminder, types of triangle. Now, as we have seen, triangle is also a polygon because, as you saw in the definition of a polygon, basically any shape which is basically a closed shape coming when 3 lines are connected. Okay, a plane connected by at least 3 or 4 lines or even more. So the shapes formed here, the one we are specifically looking at, is called what? Is called a triangle. Now, this type of a triangle, rather this type of polygon that we are looking at, calling it a triangle, has got properties, okay? Has got several other properties. Now, one of the property being the property used to describe it, you see? So what we are actually trying to say here is that a triangle, being a polygon, can be described as equilateral in case all the sides are equal. Now, it also turns out that for a triangle, where all the sides are equal, also all the angles inside are equal. In other words, the interior angles are all the same. That is, this one is 60 degrees, this other one 60, and this other one is also 60 degrees. This type of a triangle is called an equilateral triangle. The sides have got the same length. This side has got the same length as this, and that indicated with this one, this 1 bar. The other type of a triangle is this other one, is called isosceles triangle. Now, this type of triangle has got 2 sides with the same length, but the third side has got a different length. Now, the other interesting thing here is that the other angle, the base angle of these 2 sides that have got the same length, these base angles here, this and this other one here, they have the same value. Okay, these 2 angles have got the same value. These 2 sides have got the same length. These 2 angles have got the same value. This type of triangle is called what? An isosceles triangle. The other type of a triangle next is called scalene triangle. Now, it turns out that this type of triangle has got different length for all the different sides. You can see here, this length is different from that. This other length is different from the other one. So basically what you have is all these different angles are different, since all the different sides have got this different length. The length of this first side is different from the length of the second side, and the length of the second side is different from the length of the what? Of the third side. So you see, this type of polygon has called a triangle, again, has its, properties, giving it different names. We have here equilateral, all sides the same, all angles the same, isosceles, 2 sides the same, the third side different, 2 angles the same, the third angle different, okay? Then scalene triangle, all the different sides have got different length, and all the different angles has got what? different values. So these are just three when we are describing what? Triangles by their side. Now we will move on to look at what? How to describe triangles based on the internal angle. Now, the first one being what is called the right-angled triangle. In a right-angled triangle, the first one of the angle is 90 degrees. Normally, it's indicated with a small box, a small square, as you can see here. That means 90 degrees. And any triangle where one angle is 90 degrees is called a right-angled triangle. Then there is this other one here, which is called acute-angled triangle. Now, for an acute-angled triangle, all the angles inside are less than 90 degrees, okay? All the angles you see here, 90, less than 90, this less than 90, just like that one. This type of triangle is called what? It's called acute-angled triangle. Then the third one being oblique-angled triangle. What this means is that one of the angle is greater than 90 degrees. The other ones less than 90 degrees, okay? So one of them is at least greater than. So you see, when it comes to description of triangles being a polygon, when it comes to this type of description based on angles, then we will base ourselves on what? On the standard angle being 90 degrees. If the angle is 90 degrees, or if at least one of the angle, rather, if one angle inside a triangle is 90 degrees, that triangle is called a right-angled triangle. If all the angles are less than 90 degrees, then it is called acute-angled triangle. If one of the angle is greater than 90 degrees, then it's called an oblique triangle. Okay, so we saw that we are just moving on as what? As quick as possible. Now, the other property that we also discussed quite briefly was what? Was this exterior angle property. Now, remember, while we were investigating, while we were talking about this equilateral triangle, while we were discussing the equilateral triangle, one thing we saw is that the interior angles are all the same. We saw that A being 60, B being 60, and C being 60. And one thing we noticed there is that when you add 60 to 60 to 60, what you get is what? Is 180 degrees. Now, the property we want to look at this moment in time is called the exterior angle property. It's called the exterior angle property. Now, what this means is that there are properties that we can use called the exterior angle property, sometimes referred to as the exterior angle theory. Now, what this property means is that if you add two interior angles of if you add two interior angles of a triangle, you must get the opposite exterior angle. So very much like saying, if you add A to B, you must be able to get what? Well, let's deal with this first. If you add A to B, you must be able to get E as indicated here, you see? So these angles A and B, they are interior angles and they are opposite to this other angle E. So the sum of any two interior angles must add up to one opposite exterior angle, meaning if we add A to B in the first diagram, we must get what? We must get E. In the second diagram, if we add A to B, we must get D. You see? Now, if we add B to C, okay, we started with AB. Now, if we add BC, we must get F. If we add CA, we must get what? We must get E. You see how rotational it is? Well, it turns out that A plus B gives D, because these two interior angles must give us what? The opposite exterior angle. Then if we add B to C, we must get what? F. And if we add C to A, we must get E. This property, which is also known as the exterior angle theory, is a very important property. We will be seeing in, one or two examples right away here. You see? So like, for example, in this first case, we are supposed to find the value of x. How do you find the value of x? Well, it turns out that this angle x degree and this other one must add to give us this opposite exterior angle, because we have already seen that any two interior angles must add to give us what? One opposite exterior. You see that? So we can use that property. We can use that property with ease, and we find the value of everything that we are looking for. Okay? So very much like, okay, just extending this a little bit. All right. Okay, so this is our original triangle. And we have seen that A plus B must give us E. That is, two interior must give us what? When added, two interior angles when added must give us one opposite exterior angle. And we can use that property here. When we add these interior angles, X and 90, remember, as I indicated a little bit earlier, this small box means 90 degree. So when we add X to 90 degree, we must be able to get what? We must be able to get 122 degrees. And so we are supposed to find the value of X in that case. What that means is, well, let's use this board here to do that bit of the calculation right away. So now when we add X, okay, when we add X in degrees, just create a little more space here, right? Okay, there we go. So this is activity 1, activity part 1. What are we supposed to do? We are supposed to find the value of X in this case. Now, to find the value of X, we use the property that two interior angles must add up to one opposite exterior angle. The interior angles in this case includes X and what? And 90. That means if we add X to 90, we must get the opposite exterior angle, which is 122. Now, in this case, we can get the value of X when we do what? When we transfer 90 to the right-hand side, which is going to give us 122 minus what? Minus 90. From here, we can find the value of X. And the value of X in this case is going to be, well, what is 122 minus 90? Right away, let me get my calculator on board. So what we are going to do is we have to, well, here is my calculator. Let me first place it briefly this side. We have 122, and from it we are taking away 90. What do we get? We get 32 degrees. Well, yes. So this is what we get. This is 32 degrees. So this is the value of what? This is the value of X, which then means, okay, this value of X then means that, no, this one, we don't need it here. So this value of X then means that this 32 degree plus 90 degree must give us 122. So that is how we find this first value of X. Now, in finding the second value of X, we notice that 2X here and this other angle, 103 minus X, must add to give us what? That other value. You see? So in the second activity, well, if this was the first activity, then in the second activity, we say activity 2. In the second activity, we are supposed to find the value of X. How do we do that? Well, we have to add these two interior angles, 2X and this other one here, 103 minus X. We make it equals to what? To 6X minus 7. Well, what are we dealing with? We are dealing with 2X that we have to add to what? We have to add to 103 minus X. Well, these two angles, when added, must give us the other opposite exterior angle, which in this case is 6X minus what? Minus 7. See that? So that is from this angle, exterior angle property. Two interior angles add up to give one opposite exterior angle. Well, what will that give us? It will then give us, well, let's open the bracket first. This is going to be 2x plus what? Plus 103 minus x equals to what? Equals to 6x minus 7. So in the next step, we can now collect like terms. We are going to be having 2x minus what? Minus x. What we have done is to get this close to that. Then later we also have to bring this 6x onto the left-hand side. Now notice that 6x is positive on the right-hand side. And so on the left-hand side, it's going to be what? It's going to be negative. Then on the right-hand side, we are going to be remaining with negative 7. And onto it, we add this other one here. We transfer the 103 onto that side. When we do that, we are going to be having negative 7 minus 103. Now, precisely what we have done is this. After opening the bracket, we decided to collect like terms. Now, collection of like term in mathematics very much means quantities with some unknown value must be put together. And then the other quantities that are referred to as constant values must be put on the other side of the equal sign. What this then means is that 2x will be put together with x. Why? Because 2x has got x in it, and this other one has got x, and there is also one x here, which is what? 6x. So when we transfer onto the left-hand side close enough to 2x, the other quantities involving x, we are going to be having 2x as the first, then negative x, then what? 6x, which is going to be negative on the left-hand side. Remember, every quantity after crossing the other equal sign, it changes sign and it becomes either minus if it was positive, or it will become positive if it was initially negative. The same way on the right-hand side, now we have what? We have negative 7. So we have to transfer 103 onto what? Onto the right-hand side, still in the process of collection of like terms. So in the next step, we now add these quantities up. Now, notice that when we take 1x from 2x, we get what? X. Now again, when we take 6x from 1x, we get what? We get minus 5x. So that's what we are going to be left with on the left-hand side. Now on the right-hand side, well, negative 7 minus 103. What's that going to be? Well, just really quick, to make it a lot easier for you to see, we can use the calculator for that. So it will be like negative 7, we'll be having negative 7 well, how are we going to write negative 7 here? Negative 7 is written with this, yes, minus 7 minus, oh, all right, sorry. We first needed to remove this. Okay, so what we are going to be having is negative 7, that is 7 negative, minus 103. See how we write that? Now, notice that before you start any calculation, you must ensure your calculator does not have any number written on it. Otherwise, the calculator will not know that you are doing a new calculation. It will just add the number that you are putting in into what is already there, and that's not a good thing. So the first step is to clear the calculator so that it is not having anything on the screen. Then you write the number correctly, s minus 7 minus 103. What that gives you is 110, which is what? Which is negative. So we are going to be having negative 110. In the next step, to find the value of x, we now divide negative what? Negative 5x by what? We divide it by negative 5. Why do we do that? Well, because we want to find the value of x. So when we divide negative 5x by negative 5, what we are going to be having is going to be only x on the left-hand side. Now, notice that because we have divided the left-hand side, which is negative 5x by negative 5, we also do the same onto the right-hand side. That means we also have to divide the quantity on the right-hand side by what? By negative 5. When we do that, what we will find is the value of x in degrees. And so we say x is equals to what? Well, what is 110? divided by 5? Rather, what is negative 110 divided by 5? So let's have this calculation right here. We first clear the screen, then we'll be having 110, which is negative, okay? We then later divide it by what? By 5. 5 is also negative. What do we get for that? We get 22 degrees. We write it here as what? As 22 degrees. So this is the value of what? This is the value of x. And that is how we calculate x in this case, okay? That's how we calculate x. So what that means is that this upper angle, okay? What we are dealing with now is that this 2x for this other angle here, this angle here, is going to be 2 times what? 2 times 22. And what is 2 times 22? Well, 2 times 22 is 44, okay? Then now, the other angle, which is 103 minus x. This angle here is now going to be what? Well, this angle is now going to be 103 minus 22. So we are going to be having 103 minus what? 22. What will this one give us? Well, 103 minus 22, it's going to give us, well, let's check really quick. 103 minus 22, it's going to be 81 degrees. 81 degrees, okay? Then for the third angle, which is what? The third angle, which is 6x minus 7, well, the third angle is 6x minus 7. So for this angle, which is 6x minus 7, what we then get, what we are going to get for that is going to be 6 times 22. 6 times 22 minus 7. Well, what are we going to get for that? Well, 6 times 22 minus 7 is going to be, let's check with our calculator here. 6 times 22, then later from it we take away 7, we get 125. Yes, so that's what we get, 125, like that. So these are the different angles. Notice that when you add 44 degrees to 81 degrees, what you get is 125. There is no doubt about that. So this plus that add up to give us one opposite exterior angle. See that? Now, we could add one more example to this calculation of ours. And what is that? It's this angle here. Well, now the interesting thing in this angle is that, well, the interesting thing in this angle is that they have not given us any value, but they have written this, this, and that. What that means is that this angle here is equals to this angle and it's equals to the other angle. So then how are we going to deal with it? How are we going to handle this type of case? You see that? How are we going to handle this type of case? Now, to handle this type of case, just let me bring our mathematical board this side. Oh, sorry. I was just trying to transfer it to the other side so that we can have where to write. All right, let me just put it here. Yes, it has accepted there. Now, this is going to be activity 3. Let me just call it activity 3 right away. So this is activity 3. Now, in activity 3, what we are supposed to do is to find the value of x, which is the opposite exterior angle to this other one here. It's opposite to this and that. Now, before we find the value of x, we need to find these angles here. Now, let's say the interior angles are represented by y for each. So this is y, and this is letter y. So that means when we add y to y, okay, when we add this one to that, we must be able to get what? We must be able to get x. But we don't know the value of y. How can we find the value of y? Now, to find the value of y, we must add this value here, which is also y, to this one, then to the other one. When we add all the three values of the angles inside a triangle, we must get 180 degrees. In statement, the interior angles of a triangle add up to 180 degrees. That means when we add the angles inside this triangle, we must be able to get what? 180 degrees. That then means 3 of y is going to be equals to what? 180. Because when we add y to another y to another y, what we get is 3 of y. It's very much like when you're adding oranges or something that you have, like you add this phone to the other phone to the other phone. You have 3 phones. You have 3 of p if a phone is represented by p. So we are going to have 3y equals to what? 180. So from here, what can we do? Well, from here, we can find the value of y. So how do you find the value of y? To find the value of y, we have to divide this 3y. Just a minute. We have to divide this 3y by 3. Now, notice that because we have done this on the left-hand side, also on the right-hand side, we must divide 180 by what? By 3. That is, whatever we do on the left-hand side must also be done on the right-hand side. Now, this way we can find the value of y. And what will it be equals to? Well, it's going to be 60 degrees. Now, that's going to be the value of y. 60 what? 60 degrees. Now, after finding the value of y, okay, we go and do what is called back substitution. Okay, we do what is called back substitution. Now, what back substitution means is that from y, okay, plus y equals to x, which we had indicated a little bit previously. Check here. Okay, we had written that y plus y equals to x. Now we have got the value of y. So what we want to do now is to find what? Is to find the value of x. We got that y equals to 60. And so we add 60 2 times. That must give us the value of x. Now notice that when we add 60 2 times, what we get is 120 degrees. And so therefore we can say 120 degrees is the value of x. Now that is how we carry on this type of calculation. Okay, now this calculation is based on the fact that what? That 2 interior angles add up to 1 opposite exterior. But they added also another property that the sum of interior angles of a triangle must give us 180 degrees. So that is how we would find the value of x. Now, here is an activity for you. Please go ahead and find the value of x in this activity 4, in activity 5, and in activity 6. Now, notice that when you're finding the value of x in activity 4, then you will add 7x to 5, and you add that to 84 degrees. Now, when you add these two, you must be able to get what? 17x minus 1. In other words, for activity 4, just to make it a little bit easier for you to see, in activity 4, let me put it here. So in activity 4, activity what you're going to do is you will add 84 degrees, okay? To what? You will add 84 degrees to 7x plus 5. Then you equate it to 17x minus what? Minus 1. This way, you can find the value of x with a lot of comfort. Now, for the next activity, which is activity 5. So for activity 5, notice that what we are dealing with in this case is what? What we are dealing with in this case is these two angles being opposite to 130 degrees. So the equation is going to be, for the first one, well, you may not need to put it inside the bracket, but it's also fine to put it inside the bracket. Well, the first thing is that we are going to add 14x to 6. 14x to 6, which is this first angle here. We add it to what? To 16x plus 4. We add it to 16x plus 4. Then we make this equals to what? 130 degrees. Now from here, you will be able to determine the value of x. Then now in the next activity, which is activity 5, rather activity 6. In activity 6, to find the value of x, what you're going to do, well, let me move our mathematical board a little bit this side so that we have proper space. Okay, so you will add this angle to that and you make it equals to 11x plus 3. That way, you can find the value of x. So what are we going to have? Well, we are going to have 5x minus what? Minus 10. We are going to add this to 85 degrees and we make it equals to what? Equals to 11x plus 3. Now, I'm just going to do this for you so that, you know, you don't have too much to struggle with. So now what we are having here is that, well, we have to find the value of x. So to find the value of x, we are going to do what is called collection of like terms. Collection of like terms means we are going to transfer 11x onto the left-hand side to this 5x. Then everything else, this 10 and this 85 will be moved onto the right-hand side. Now remember, we could also transfer 5x onto the right-hand side so that we put 5x close to 11x. Then we transfer 3 onto the left-hand side. The answer must be the same. All right, let me call these different methods. So I'm going to call this one method 1. In method 1, I'm going to transfer 11x from right-hand side to the left-hand side so that we get 5x minus 11x. Notice that it's going to be minus 11x because 11x is positive on the right-hand side. And so on the left-hand side is going to be negative. Now on the right-hand side, we are going to be having 11 added, rather we are going to be having 3 added to 10. And from it, we take away what? 85. Why have we done that? Well, what we have done is to transfer 10, which is negative on the left-hand side. And remember, when we transfer 10, which is negative on the left-hand side to the right-hand side, it becomes positive. And when we transfer 85, which is positive on the left-hand side, it becomes negative on the right-hand side. That is why we have positive 10 here and negative 85. Now, notice that what we are going to be having on the left-hand side is going to be negative what? Negative 6x. Now, this negative 6x is now going to be equals to what? It's going to be equals to, well, we got negative 6x after taking away 11 from 5, which, you know, you could see for yourself here. So 5 minus 11, what do we get? Well, 5 minus 11 gives us negative 6. Then now for what we have on the right-hand side here, well, for what we have on the right-hand side, we have 3 that we have to add to 10, and from it we take away 85. What we get from there is negative 72. And so we write it down as negative 72. Now, in the next step, we want to find the value of x. So the value of x is going to be calculated when we divide negative 6x by negative 6. In other words, negative 6x, okay, when we divide by -6 right here, when we divide this by -6, we will be able to determine the value of x. But before that, we also have to divide -72 by what? By -6. That is, what we have done on the left-hand side must also what? Must also be done on the right-hand side. So we also divide -72 by -6. What is that going to be? Well, that is going to give us the value of x. And so what is x going to be equals to? Well, this time we are going to write -72, that is 72, negative of it. We now have to divide by what? We have to divide by 6. And remember, 6 is also negative. And so what are we going to get? Well, we are going to get 12 for x. And so we can say x equals to 12, this time in degrees. Right away. Now, the other method that I wanted to show you is the second method. Now, in this second method, what we want to do is to transfer x, which is on the left-hand side, onto the right-hand side, okay? So what we have here is this. We have this as our equation. So we want to transfer, well, okay. There we go. We want to transfer 5x onto the right-hand side. Now, transferring 5x onto the right-hand side, well, let me first transfer this. And I bring it here. So that is easy for us to see how to move on. Yes. Now, what we want to do with this second method is to find the value of x by transferring 5x onto the right-hand side. There are always so many ways of dealing with this type of stuff. So what we are going to do is we are going to leave -10 on the left-hand side and also 85 onto the left-hand side. Then we are going to bring 3 onto the left-hand side. Then onto the right-hand side, we are going to be having 11x. And from it, we take away what? We take away 5x. What we have done is to transfer what? To transfer 5x onto the right-hand side. Then bring 3 onto the left-hand side. Now, notice that what we are going to have for left-hand side, well, can be calculated using a calculator. So we'll be having -10, that is 10, negative of it. Then we are going to do what? We are going to add this to 85, okay? Then from 85, we take away 3. What do we get here? We get +72, which we write down here. So this is going to be 72. On the right-hand side, we are going to be having 6x. You see that? So now from here, we have to find the value of x. How do you find the value of x? We find the value of x by dividing 72 by what? 72 by 6. Then now what we have on the right-hand side, which is what? Which is 6x, is also going to be divided by 6. So now when we divide 6x by 6, what we get is x. And so we can confidently say 12 on the left-hand side is now equals to what? Is now equals to x, which is on the right-hand side. So this is how we determine the value of x. So there isn't any problem. You can decide to do the collection of like terms in such a way that the unknown in the equation appears on the left-hand side, or you can do it in such a way that the unknown in the equation is going to appear on the right-hand side. The side of the equal sign where the unknown is going to appear will not affect the final value of the unknown. But the easiest way is always to transfer the smallest unknown onto the bigger side of the unknown so that you avoid dealing with negative signs during the process of the calculation. Now, this one is supposed to lead us to the end of this lesson. So please use this property of what? This property which we are calling the sum of the interior angles. That is, 2 interior angles add up to one opposite exterior angle. 2 interior angles will add up to give you one opposite exterior angle. Use that to do what? To handle activity 4 and activity 5. In our next lesson, we will then be looking at how to calculate the area of a given triangle, still under polygon and still under what we call Euclidean